Whenever you have an even number, what was that going to lead to? Disinhibition and firing of that neuron. That is the direct pathway. Okay? How about this pathway right here? This is one of the indirect pathways. By the way, the reason they're called indirect pathways is they have more intervening neurons between the striatum and the thalamus. Okay? Well, what do we have here? GABA, 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 GLU. What did we say? That's an odd number. Okay? So what's odd number lead to? Inhibition. Good. So that's a break. That's a braking pathway. Now, the most famous indirect pathway is the one you see at here. It comes, I have it in yellow. It's in dark lines. Oh, actually, it starts here, goes up here, and goes here. Okay, let's just do this part of the pathway. We have GABA, GABA, GLU. Okay. And what's that mean? What happens to this neuron?
Firing.
It fires. But look what it activates. The GABA, which does what? It inhibits movement. There's another braking system. Right? So the indirect pathways, we showed the major ones. The indirect pathways are brakes. Okay? The direct pathway is the gas. Now, here is, all this occurred before dopamine arrived. Okay. Now, we have down here dopamine. Now, look what dopamine does to the direct pathway. What does that plus mean? It excites it. Okay? Well, it turns out in the direct pathway, these neurons right here have D1 receptors. On those GABAergic neurons, you have D1 receptors. And the D1 receptor is an excitatory receptor. So, dopamine acting via that pathway excites, okay, the gas. It excites the gas, which means we get what? More movement. You with me so far? Okay? Now, in the indirect pathways, dopamine inhibits. On these indirect pathways, you have D2 receptors. And D2 receptors are inhibitory. And what did we say those pathways, those indirect pathways were in the first place? They were what? Inhibitory pathways. If we inhibit the inhibitory pathways, that's like taking the brakes off. That's like taking the brakes off. You inhibit the inhibitory pathways. Before dopamine arrived, the indirect pathway, the major indirect pathway, was inhibitory. Dopamine acting via D2 receptors inhibits the inhibitory pathway. It's like taking the brakes off. Okay? What about this pathway up here? This pathway had 1, 2, 3, so it was inhibitory. Okay, remember? What does acetylcholine do to that pathway? Acetylcholine is excitatory to that pathway. So, if acetylcholine is released, what happens? We do what? We put on the brake. Now, if I were to ask you, what type of agonist is going to give you the maximal activity. Would it be a compound that's a selective D1 agonist? Would it be a compound that's a selective D2 agonist? Or would it be a compound that has both D1 and D2 agonist activity for maximal movement?
D1 and D2.
The one, what?
Both.
Yep, the one that has both.
Yes.
Because via the D1, what will we do? Excite the direct pathway, which is like it's a disinhibitory pathway, but it's an excitatory pathway to movement. By activating the D2, what are we doing?
Inhibiting it.
Inhibiting the inhibitory pathway. In other words, we're taking off the brakes. To make your car go the maximum, okay, you have to put on the gas, but at the same time you have to take off the brake. And via D1 and D2 receptors, okay, you will get maximal movement. Now, what did we say about acetylcholine? It activates what?
The direct.
Inhibitory pathway. It's like putting the brake on. It's like putting the brake on. You with me? Now, it's getting complex.
Direct is inhibitory.
So here's what you need to think. Whenever you think of the basal ganglia, what you need to think of is there's a balance between dopamine and acetylcholine in this area. Okay? There's a balance between them. What happens if the balance tips towards the acetylcholine side? What do you get? Less movement or inhibition. What happens if you tip it towards the dopamine side? More movement. So, in other words, the two neurotransmitter systems are antagonistic to one another. Now we've got to talk about what happens. Okay. By the way, this area down here where the dopamine neurons arise from is called the substantia nigra. The substantia nigra, or SN. Those of you who speak Spanish, what does that mean? Black substance. Now, what I want to do is show you a picture. Here is a normal person. See this area right here? That's the substance. There's two of them. This thing didn't Xerox very well, but that's the substantia nigra. It's in the upper brainstem. We sometimes call it the midbrain. It's in the upper brainstem. Okay? What happens is, this area is pigmented. The reason it's pigmented is because L-DOPA is not only the precursor to dopamine, L-DOPA is the precursor to melanin. Okay? So the area is pigmented. The substantia nigra, those neurons, not only are they producing dopamine, but you're also producing melanin, which pigments the area. What's the difference between the person normal and the person in Parkinson's disease? Okay. What do you see? You see very little, if any, pigmentation whatsoever. And the reason you don't see that pigmentation, what do you think the reason would be? You're destroying those neurons. The neurons that make dopamine are being destroyed. Now, in fact, everyone in this room, okay, is losing those neurons at about a rate of 10% per decade of life.
Oh, no.
That's why athletes aren't as good as they get older. They're starting to lose those fine movements. Okay? Gymnasts, everybody, we all lose them at a rate of 10% per decade of life. By the way, when you're in your teens, what decade of life do you think? Second. So, if you're in teens, you're in your second decade of life. Okay?
Yes.
So if you're in your 40s, what decade of life are you in?
Is that
Fifth decade of life. Right?
2 months?
From 0 to 10 is your first decade of life. From 10 to 20 is your second decade of life. So when you're in your 40s, you're in your fifth decade of life. Here's the thing about Parkinson's disease. It's not until you lose 80% of those neurons, 80%, that you first get the symptoms of Parkinson's disease. So let's figure. How many decades of life, if we're losing a 10%
70s.
per decade of life?
The 70s.
Okay. How many decades before we get to that 80%?
7.
But 4.
Actually, wait a minute.
4.
I am so off on this.
You're done with 80% after 8 decades.
Okay.
After.
Yeah, that's
You're
right.
losing at a rate of 3 to 5%.
Oh my God! Thank God.
I knew something was wrong.
I know. I was like, oh my God, we're gonna die soon.
I'm almost done.
3 to 5%. So half is right. 3 to 5% per decade of life. Okay.
80%.
Well,
How can you lose 80%?
how many decades would it take to reach 80%? Let's say 5%.
16.
16 decades, which means you would be 160. Okay? So most of us, okay, aren't going to experience Parkinson's disease unless you're living biblical term life expansion. However, in Parkinson's disease, for some unknown reason, the destruction occurs at a quicker rate, whether it be environmental or whatever's going on. Okay, you lose it at a quicker rate, somewhere around 10 to 15% per decade of life. Okay, that means somewhere in this, around the 8th decade of life, you've reached that 80%. Your 15% is even less. Okay, so Parkinson's disease, for the most cases, is a disease of the elderly. Okay? A disease of the elderly. If we lose the dopamine neurons, okay, what happens to the balance between acetylcholine and dopamine? It goes towards the acetylcholine side, which is what? Which is no-go. Dopamine is go. Acetylcholine is no-go. Are you with me? You can follow? It's kind of complex, but you're getting there. Okay. Now, one last thing. Couple last things. There are several dopamine pathways in the brain. We're just talking about one of them. Okay? This is called the This is called the nigra. Substantia nigra, they call it the nigral. And it's projecting to the striatum. So this is called the nigro-striatal dopamine pathway. The nigro-striatal dopamine pathway. It's one of many dopamine pathways in the brain. Later on, we're going to talk about other dopamine pathways that are involved in schizophrenia. But right now, we're talking about the nigro-striatal dopamine pathway. Then, the next thing, if you were to really look at the structures of these glutamate neurons and look them under a microscope, if you look